According to Dalton's atomic theory, atoms are indivisible. So they, at that point in time, they did not know that there were certain particles called the subatomic particles that did exist in the first place. By the end of the 18th century, sorry, the 19th century and the beginning of the 20th century, subatomic particles had been figured out. So there were certain questions that scientists had to answer. First was how was the atom stable? So they did not know how the atom could be stable, and they didn't know about the arrangement of the electrons, protons, and neutrons. And the second was they how were the elements different from each other in terms of physical as well as chemical properties. So I think in grade 9 you had studied about the basic differences between atoms, and like they have a different number of electrons. All of that is something we know now. But then scientists didn't know how elements were different from each other. There was also a question as to how various molecules were formed, and the last was to understand the nature of the electromagnetic radiation which were absorbed or emitted by the atoms. So this particular point we will be coming back to again when we talk about atomic spectrum. So all of these questions had to be answered, and so various atomic models were put forward for explanation of the structure of the atom. The first one we're going to be studying about is JJ Thomson's model of the atom. It was proposed by JJ Thomson in 1904. So as you can see, I've put a picture of watermelon because this is also called as a plum pudding model, um, or or even a raisin pudding model. So, according to JJ Thomson's theory, the red part of the watermelon is the positive charge, and the seeds are the negative charges which are embedded in it. So, he said that atoms possess a spherical shape and they have a radius of 10 to the power minus 10 meters, and the positive charge is evenly distributed, whereas the negative charge is embedded. And this is present in such a way that they have a maximum electrostatically stable arrangement. So there is not a lot of issues in terms of instability. So the advantage of JJ Thomson's model of the atom was that it was able to explain the electrical neutrality of the atom, but there were certain experiments which we'll be talking about next that were not proved. I mean, this particular model of the atom was not able to prove. So in comes Rutherford's model of the atom. So Rutherford, along with his students Heinz Geiger and Ernest Marsden, in 1911 performed these experiments called as Rutherford scattering experiments. So what they did was they bombarded a gold foil with a beam of fast alpha particles. In the previous video, we had studied about what alpha particles were. So this thin foil is 100 nanometers thin, and this alpha particle source is placed inside, and it's radium. So it is placed inside a lead box with slits in between to ensure that they got a fine beam of light, and this was detected by a fluorescent screen, a zinc sulfide screen. And then when these alpha particles hit from the radioactive source of they hit the gold foil, the observations were made. So based on JJ Thomson's model of the atom, we should have observed that the alpha particles, moved straight through. But that was not the case. So this was the reason why JJ Thomson's I told you, right? So JJ Thomson's model of the atom was able to explain the neutrality of the atom, but it did not explain the results of this experiment. So according to JJ Thomson's model of the atom, this should have been the observation that Rutherford and various scientists, his students, had made. But this is what he observed. First, he saw that most of the alpha particles pass straight through. So as you can see over here, most of these alpha particles, that is, all of these are passing straight through. Next, a small fraction are deflected at small angles. So very small amount of them are deflecting at angles, and very few of them bounced back, or they were deflected at nearly 180 degrees. If you notice, even in this experiment, you have majority of the rays passing straight through. You have some deflected, very few you have them almost at like deflected at a very high angle. So these observations led to the following conclusions. First of all, because there is a large number of alpha particles which just pass straight through, he said that there is a large amount of space inside the atom. Second, some of them were deflected at certain angles, which meant that there should, if you see, there should be a heavy positive charge. So first of all, alpha rays themselves are positively charged. So due to repulsive forces, they were deflected by a small angle. And the next one, strong deflections were due to the particles with a heavily positive charged mass. So the deflection over here is because of them hitting the some object that was positively charged and it was heavy. Remember one thing, neutrons were not discovered by then. It was only protons. They assumed that protons were present over here, and this particular heavily charged, this was heavy. If you think about it, protons are heavier than electrons and much heavier than the electrons. So this deflection meant that this particle was like heavy, and that's why this deflected at almost 180 degrees. So based on the observations and the conclusions, these are the postulates of Rutherford's nuclear model of the atom. So most of the atom is empty. This is obviously because he noticed that the alpha particles passed straight through. The second is the positively charged, and the most of the mass of the atom was concentrated in an extremely small region. And this is called the nucleus. This was called nucleus by Rutherford. So so because you had the two observations, which he noticed that there were slight deflections and a very few amount uh, deflected straight back. He said that the positive charge and most of the mass was concentrated in the center, and this particular area is also called the nucleus. The nucleus is surrounded by electrons, and they move at very high speed at circular paths called as orbits. So he said that electrons were rotating around the nucleus, similar to what you see in our solar system. The Earth rotates around, rotates in its axis and undergoes revolution around the sun. And so it's similar to that. So, but yeah, there you have it as an oval shape and stuff. But this is a circular orbit, and the electrons and the nucleus are held together by the electrostatic force of attraction. Obviously, there will be some amount of attraction between the positively charged protons and the negatively charged electrons. So these are held together by the electrostatic force of attraction. So these were the four um, points of Rutherford's model of the atom. But there were two important drawbacks of Rutherford's theory. First, it was not able to explain the stability of the atom. So there was something called as law of Maxwell's theory of electromagnetic radiation. So according to that, when you have a body moving under the influence of attractive force. So here you have an attractive force between the protons and the electrons. So when the electrons move around this these protons, it will tend to lose energy in the form of electromagnetic radiation. So in basically what will happen is when the electrons rotate around the nucleus, according to Maxwell's theory of electromagnetic radiation, electrons will lose energy. So what will happen is it'll keep going round, 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 and then it'll land up falling inside the nucleus. That will lead to the collapse of the atom. But that is not something that we observe right now, right? Atoms are supposed to be stable. If this was the case, then none of us would exist in the first place. So these the main this was one of the main issues. So Rutherford's theory did not explain the stability of the atom. The second was it was not able to explain the distribution of the electron. I think in grade 9 you would have learned about Bohr's theory. There it says you have two electrons, and then in the first shell you have eight electrons in the second shell, and so on. So based on that, you had concepts of valency and all of that. But according to Rutherford's theory, he did not talk about where the electrons are present. He just said that the electrons and protons are held together by electrostatic force of attraction. So these were the two main, or two rather very important drawbacks of Rutherford's theory. So in this video, we had learned about JJ Thomson's model of the atom, the gold foil experiment, the observations and the conclusions of the gold foil experiment, and the Rutherford's model of the atoms, and the two major drawbacks of this particular model of the atom. So with this, we complete the two models. In the next video, we will be studying about atomic as well as atomic mass, sorry, the mass number and the atomic number.